Hello my dear students, welcome back again. As we have seen in part 3 of grade 12 mathematics, Ethiopian University entrance examination in English, we try to solve some of the problems that are related to the entrance examination. Today we will see part 4 and the next questions or the next problems that are related to the university entrance examination. Let us begin with question number 9. Question number 9. Question number 9 says, what is the sum of all multiple of 3 between 20 and 200? Multiple of 3 between 20 and 200 can be written as 3n less than 200. Again, this 3n is also greater than 20. Now, to know the first term and the last term, what we have to do is we have to divide by 3 both sides. Here, this must be divided by 3 and this must be divided by 3. Then remove this 3 from here. Just for the time being, keep it. If we divide this one 20 by 3, we will get a number 6.66 repeating. It is a decimal number like this one. And again, if 200 is divided by this one, we also will get 66.6 repeating. 0.6 repeating. Now, since our n is a natural number or positive integer, then take a natural number which is greater than 6.6 repeating. That number is going to be 7. And also take a natural number which is less than 6.6 repeating. That number must be equal to which is less than 6.6 is going to be 66. If we multiply these two numbers by 3, if we multiply these two numbers by 3, we will get the first term. We will get the first term, which is equal to 21. 21 is considered to be the first term, which is a multiple of 3 and or divisible by 3 and greater than 20. And also, if we multiply 3 by 66, we will get also again this number, which is equal to 198. That is going to be the last term of the sequence. This is a multiple of 3 which is less than 200, and therefore we can consider it as the last term. That is the whole point. Once we get the last term and the first term, then put both here. Our A1, the first term, is going to be 21, and also the last term, the nth term, is also an is equal to 198. The point here why we take A1 and an as if this sequence is an arithmetic. Of course, this sequence is an arithmetic because 3n, multiple of 3, is written as 3n, and therefore any linear expression in n are considered to be an arithmetic sequence. Any sequence that are expressed linearly in n, in terms of n, are said to be an arithmetic sequence. That is why I put this one here. A1 is equal to 21 and the an is equal to 198. In that case, 3 is going to be again the common difference. Since this is because let us observe, we once we get the first term, our first term is 21 Then the next term, that is multiple of 23, I mean the multiple of 3 is 24. 24. The difference between 21 and 24 is 3. And the next term, which is multiple of 3, is also 27. And therefore the difference between 27 and 24 is also 3. And the next term is going to be 30. And the difference between 30 and 27 is also 3. And therefore our common difference, this is an arithmetic sequence whose common difference is exactly equal to 3. Just put it like that one. And if we continue as such, 30, 33, and so on, then the last term, which is divisible by 3 and less than 200, is 198. Just keep this information. Keep this information. Once we know this data, terms of the sequence, particularly the last term and the first term, and also the common difference, it is easy to find the sum of those terms, since the sequence forms an arithmetic sequence. Now let us clean this area, please. For convenience, let us clean this area. To find the sum, now something is missing. These are sufficient. The first term and the last term are sufficient, but they are not enough. And therefore we need to find another variable. We say the sum of the first n terms of an arithmetic sequence, provided that we are given the first term and the last term and also the number of terms, we say Sn, the sum of the first terms, we say like this one here. Let me undo this thing. Sn, suppose that is n. Sorry for my writing, I am again improving it. Here, n over 2 a1 plus an. This is the formula to find the sum of the first n terms of an arithmetic sequence. If our last term and first term are given, and also the number of terms, if we know the number of terms. But what is missing here? The missing variable in this case is n. We don't know the number of terms. To find this sum, we have to know the number of terms of this sequence, the number of terms that are divisible or multiple of 3 between 20 and 200. How can we obtain that n? Just use these three variables. We know that the nth term of an arithmetic sequence is given by an is equal to, remember this formula always, a1 plus n minus 1 times the common difference d. n minus 1 times the common difference d. Now we have an, a1, and d. It is simple to find the value of n, the number of terms in this case. Our an is 198, and our a1 is equal to 21, and the common difference is 3. Therefore multiply n minus 1 by 3. Multiply n minus 1 by 3. Here let us multiply n by 3. This by 3. Okay, here this becomes 198 is equal to 21 plus 3n multiply 3 by n multiply 3 by minus 1. 3n minus 3. This becomes 3n minus 3. And finally, we will get this number. This number becomes like here. 21 minus 3 gives us 18, 18, plus here we have 3n. Here we have 3n. Here we have 3n. If we solve for n, then our n is equal to, this is linear expression, our n is equal to 60. Now we have 60 terms. These terms, each of these terms are a multiple of 3. Each of these terms is a multiple of 3 and between 20 and 200. 20 and 200. And therefore, since we get n, I hope it is easy to solve this one. Move 18 to the left and subtract 118 from 198, and then divide the result by 3. Then you will get n is equal to 60. Then put every variable. That means n, d is unnecessary to solve, to find the for this particular, to find the sum of this sequence for this particular question, since we have already n, the number of terms, a1 and an, and therefore our n is 60. Put it 60 here. 60 divided by 2, 60 divided by 2, multiplied by a1, which is 21, plus 198. The sum of 21 and 198 gives us 219, and also 60 divided by 2 gives us 30 times. The sum of the two also gives us 219. Then multiply these results. 3, when 3 is multiplied by this one, we have here, put 0 here, please put 0 here, and 3 times 9 is 27. We have 2. 3 times 1 is 3. 3 and 2, it is 5. And also 3 times 2 is 6. That is the sum of all multiples of 3 between 20 and 200. Therefore, our answer is A. If you say A, then you have done it. You get the right answer. That is A. The answer is A. Now let us see the previously done solved one. Now here, note that multiple of 3 can be written as 3n. Multiple of 3 can be written as 3n, where n is an element of natural number. Since 3n is linear expression in n, the sequence is an arithmetic sequence. The first and the last terms that are multiple of 3 or divisible by 3 between 20 and 200 are respectively 21 and 198. And our a1 is 21, our an is 109, and also the common difference is d is equal to 3. And moreover, we know that an is equal to a1 plus n minus 1 times d, and therefore now replace all the variables by the given numbers except n, which we don't know, and then solve for n, and our n is equal to 60. Therefore we have 60 terms, a multiple of 3 between 20 and 200. And also we know that the sum of the first n terms of an arithmetic sequence is given by n over 2 times a1 plus an, and therefore replace all the variables, in this case n, a1 and an, which is here n is 60 divided by 2, and into 21 plus 198, and then we will get this sum. This is the sum of all multiple of 3 between 20 and 200. This is question number 9. What is question number 10 says? Let us see. Question number 10 says here, if an in brackets is a sequence such that a1 is equal to 2 and an plus 1 is equal to an plus 4 for all n greater than 1, then the summation of n running from 1 up to 35 an is equal to, that is what the question says. That is what the question says. Now, this formula is written recursively, but what we know is the following. For a certain sequence to be an arithmetic sequence, we know an plus 1 minus an, since the two are consecutive or successive terms, always gives us the common difference. Now let us observe this one here. Put around here, our a1 is 2, the first term is 2, our a1 is 2, then no need to write a1 here, the first term is 2. What is the next term? Replace what is, when our n is 1 here, a1 is equal to 2, but when our n is again 1 plus 1 gives us 2, therefore a2 is equal to a1 plus 4. But we know a1 is already given. What's our a1? Our a1 is 2, and therefore 2 plus 4 gives us 6. The next term is 6 right here. And where our n is 2 again, 2 plus 1 gives us 3. Therefore a3 is equal to a2 plus 4. a2 plus 4, since our n we say is 2, and a2 is also 6. We have already get a2, and therefore 6 plus 4 gives us 10. 6 plus 4 gives us 10. Therefore the next term is 10. No need to write here, let us write here. The next term is 10, and so on. Now here the second term is obtained by adding 4 on the first term, and the third term is obtained by adding 4 on again the second term, which is 6, and the fourth term can also be obtained by adding 4 on the third terms, and therefore it becomes 1 4, which is 14, and the next term is 18, and so on. 18 and so on. This sequence is an arithmetic sequence. Based on these recursively formulated formulas. And then here the main point you need to know is, for an arithmetic sequence, this is always true, and this can also rewritten as an plus 1 is equal to, move an to the right, we have an plus d, an plus the common difference for all n natural number. Now for all n greater than or equal to 1, then our d in this case, this is always true, our d in this case is 4. That is the whole point. And now we are going to find this sum. We are going to find this sum. But first, let me clean this area. Once you understand this thing, this formula, then let me clean this one. What do you mean by the summation of n running from 1 up to 35? That is the first point. And moreover, we know the sequence an in brackets is an arithmetic sequence, since the terms, the successive terms are the difference between the successive terms is equal to 4, and therefore this an, the summation of n is running from 1 up to 35 is always equal to the following: 35 is going to be a1. The summation of this thing gives us a1 plus a2 plus a3 plus again plus, and so on up to a35, because the last number is 35. Just make it plus and followed by 3 dots, and then plus a35. This is a35. Since the sum of these terms gives us the sum of an arithmetic sequence, then it will be equal to Sn, the sum of the first n terms of an arithmetic sequence, and also this is equal to n over 2 times 2 twice of the first term, 2a1 plus n minus 1. We know this formula again for the sum of an arithmetic sequence: n minus 1 times the common difference. Now we have everything. We have the first term, we have n, which is 35, and we have also the common difference, which is also 4, and then put this thing here. Our d, we say d is equal to 4. Our d is equal to 4. Then this sum is equal to, our n is 35 over 2 times 2 times our a1 is also 2, as you can see here. 2 times 2 plus our n minus 1. Since our n is 35 minus 1 gives us 34 times the common difference is also 4. Then here now the operation gives us 35 over 2 divided by, 35 divided by 2, and here 2 times 2 gives us 4 plus 4 times 4, it is 16. Write 16 here. We have 1. 4 times 3, it is 12. 12 and 1, 13. 1 3. Put in bracket. And here we have 35 divided by 2, 35 divided by 2 into times the sum of this one, the sum of the numbers in bracket. 4 plus 136 gives us 140. Then if 140 is divided by 2, it gives us 70. Therefore, multiply 35 by 70 by 70 70. Then 35 times 7, this is 7 times 5 gives us 35. Write 5 here, we have 3. 7 times 3, 21. 21 and 3, 24. 24. Write 24. 245, and then simply attach this 0 here. 2450 is going to be the sum of this sequence, the indicated sequence, and therefore our answer is the one in choice C. The one in choice C. This is our answer. Now let us see the previously done example. Here, given a1 is equal to 2, an plus 1 is equal to an plus 4 for all n greater than or equal to 1. The terms of the sequences are 2, 6, 10, 14, 18, and so on. The sequence is an arithmetic progression with the first term a1 is equal to 2 and the common difference d is equal to 4. The sum of the first n terms of an arithmetic progression is given by Sn is equal to n over 2 into 2 times a1 plus n minus 1 times d. You know this formula, don't forget this formula. And then the summation of n running from 1 up to 35, an is equal to s35. Since our sequence is an arithmetic, then this is equal to 35 over 2 into our a1 is 2 and 2 multiplied by 2 plus our n is 35. 35 minus 1 is 34. Our d is also 4 and 34 multiplied by 4, and then the whole calculation gives us 35 over 2 times 4 plus 136, which is going to be 35 over 2 times 140. And then when 140 is divided by 2, it gives us 70. 35 times 70 gives us 2450. 2450. The answer is, in this case, it is C. It is C. Now let us also see the next question. I hope you understand this particular question. Now let us see question number 11. Question number 11 says as follows. Question number 11, it says, an arithmetic series has the property that the sum of the first 10 terms is half the sum of the next 10 terms. Also, its hundredth term is 95. What are the values of the first term and the common difference respectively? That is what the question says. That is what the question says. Now, let us see the meaning of the whole statement is given in this question. Here, suppose a1, a2, and so on are an arithmetic sequence. Since we are already have been told an arithmetic series, then the sum of the first 10 terms means a1 plus a2 plus and plus a3 and up to, put it here, plus dot followed by 3 dots and plus a10, and also the next term here is a11. This is, let us call this one B, plus a11 and plus A12, 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 and plus up to the next 10 terms. The next 10 terms. Now we have 10 terms here. Just put it like this one. Plus the last term is going to be A20. A20. These are the sum of all the terms. All 20 terms. All 20 terms. But this question says that the sum of the first 10 terms is half the sum of the next 10 terms, which means the sum of this one, let us put this one be S1, call it S1, suppose this is S1, and the one which starts from A11 up to 20, also call it S2. S2. Let us call it S2. Now, S1, we have been told that S1 is equal to half of S2. Half of S2. And also the hundredths term is 95. Just I have already written here. Therefore, just 100, the hundredths term is 95, means 100 is equal to 95. Just put it like this one. And then we know also again the sum of the first terms, the first n terms of an arithmetic sequence. Therefore, using the formula Sn is equal to n over 2 into 2a1, don't forget this one, 2a1 plus n minus 1 times the common difference d, n minus 1 times the common difference d. Here put the whole bracket. We know this one. Then let us come here. Having this relation between S1 and S2, then for the first 10 terms, for these 10 terms, our sum is going to be 10 over 2. The first 10 terms, 10 over 2 times 2a1 plus 10 minus 1 gives us 9 times the common difference d. This is equal to, this sum is equal to, let us call this one be S1. And this is S1 is equal to half of S2. We already say that. And therefore, this is equal to half of, again, the sum of the next 10 terms, in this case, is written as 10 over 2, because the number of terms is 10 over 2 times. Now, our first term for the next 10 term is A11, right? A11, 2 times A11 plus 9D. But also we know that the nth term, from the nth term of an arithmetic sequence, A11 is equal to A1 plus 10D. Therefore, replace A11 by A1 plus 10D. Here, this becomes, now, this cancel, A10 cancel, 10 over 2 cancel, 10 over 2 to the right. And then we have to the left, 2A1 plus 9D is equal to, we have also 1 over 2 times 2A11. Since our A11 is A1 plus 10D, then make it 2 times A1, instead of writing A11, A1 plus 10D. And close the bracket. Plus, here we have also 9D. Then, again, after some calculation, when 2 is multiplied by A1, it becomes 2a1. 2 multiplied by 10d gives us 20d. 20d plus 9d gives us 29d. And then make this equal equation as a linear. Make it linear. Linear means multiply both sides by 2. Multiply both sides by 2. If we multiply this side by 2, then it becomes 2 times 2a1 plus 9d is equal to, if we multiply this side by 2, then 2 cancel 2, and therefore we have 2a1 plus 29d. And then collect the terms that contain a1 to one side, and that term that contains d on the right side for convenience of the calculation. Now, if we move this 2a1 to the left, and also 2 times 2 times 2a1 gives us 4a1. 2 times 9d gives us 18d, and move 18d to the right. If we move 2a1 here, it is positive, then it becomes minus after it is moved to the left. 4a1 minus 2a1 gives us 2a1, and again here 18 is positive, move to the right, then it becomes 29d minus 18d. And when we subtract 18 from 29d, 18d from 29d, then we will get 11d. Then 2a1 is equal to 11d. Put this one in a shelf. And also here another statement, also it is 100's term is equal to 95, and therefore a100 is equal to 95, and therefore we have a100 is equal to a1 plus 99d, because we use this nth term, the formula which is used to calculate to find the nth term. An is equal to a1 plus n minus 1 times d. N minus 1 times d. a1 plus n minus 1 times d, and therefore we have d, the common difference. We don't know d, we don't know a1 yet, and therefore, but we know our n is 100. a100 therefore becomes a1 plus 100 minus 1 gives us 99, and then multiplied by d. This means since our a100 is 95, it is given above, is equal to a1 plus 99d. Replace a100 by 95 because it is already given. And using these two formula, using these two, number one, this one, together with the first one, which is found in equation number 1, then this can form system of linear equation. Just let us move d here. From 1 we have 2a1 minus 11d is equal to, once we move 11d to the left, then to the right we have only 0 since it is moved. And also from this one, just let us rewrite as such. Let us rewrite a1 plus 99d is equal to, we have been told that a1 plus 99d is equal to call this one be 99, suppose this is 99, d is equal to 95. This is system of linear equation involving two variables. Then To solve system of linear equation involving two variables, there are different methods that you have already learned. The first one is graphical method of solving system of linear equation, and also the elimination method, and also substitution method. Even in grade 11 you have learned the Cramer's rule or Gaussian elimination method. You can use either of these methods. Let us apply the elimination method. To apply the elimination method, here we have 2a1 and minus 11d. Then multiply the first one to equate the coefficient of d here. It is better if we multiply the above equation by 9. Now multiply by 9. Then this equation is equivalent with 9 times 2a1. It is 18a1. It is 18a1. And also 9 times minus 11d, it is 99d. And again 9 must multiply 0 to the right. 9 times 0 gives us simply 0. And write again the second expression as it is. Here we have a1 plus 99d is equal to 95. 99d is equal to 95 here. Then add downwards, both sides add downward, because d is going to be eliminated from the system. In that case, we are left with only one variable, which is a1. 18a1 plus a1, 1a1 gives us 19a1. And this is going to be again 0. The sum of these two is going to be 0. And therefore this is equal to 95 here. This is equal to 95. Then divide both sides by 19. Divide both sides by 19. It gives us a1 is equal to 95 divided by 19 divided by 19. This gives us 5. Therefore the first term we are asked, let us not forget our question, what are the values of the first term and the common difference. And therefore our first term is 5. What is our d then? What is our d? What is d? Since 11d, we say from the first equation, from this equation here, from this equation, replace a1 by 5, because we already obtained a1, and therefore here 11d is equal to 2a1 implies 2a1. Suppose this is a1 from the first equation. This implies d is equal to, our common difference is equal to, it is equal to 2 times our a1 is 5. Our a1 is 5. 2 times 5 over 11. Over 11. Divide both sides by 11. It gives us 10 over 11 in that case. 10 over 11. That is the right answer. Now we have both first term and the common difference. The common difference. As you can observe here, the calculation is a little bit different, but the results are the same. The results are the same. Therefore, the answer in this case is our 5, since it says respectively, the first term and the common difference respectively. The first one is a1 and the second one is the common difference, and therefore B is going to be the right choice. The right choice. That is question number 11. Let us see question number 12. Let us see question number 12. Here is what it says. Let an is equal to logarithm of n over n plus 1, where our n is equal to 1, 2, 3, and so on, be the nth term of a sequence. Which of the following is the sum of the first n terms of the sequence? Now the problem is that we don't know what type of sequence is an is equal to logarithm of n over n plus 1. We don't know whether it is an arithmetic or geometric or neither. But what we know is by the rule of logarithm, we say, you have learned this rule of logarithm in grade 10. Logarithm of x over y, we already know this one. Logarithm of x, suppose this is x over y, this is a common logarithm actually, in base 10, just leave the base, in base 10, is always equal to, by the rule of logarithm of x minus logarithm of y. We know this thing. Now let us come to see this one. The question is, what is the sum? What is the sum of the first n terms? We write our sum in terms of n. Let us see this one. Here our n is Sn, the sum of the first n terms is given by the summation of k running from 1 up to n ak, which is equal to a1 plus a2 plus a3 plus up to an minus 1 plus an, the last one, an minus 1 plus an. This means when our n is 1, then a1 becomes logarithm of 1 over 2. When our n is our k is our k is 1, it gives us logarithm of a1 gives us logarithm of 1 over 2. When our k is equal to 2, which means a2, then a2 is equal to logarithm of 2 plus 1 gives us 3, 2 over 3. When our n is 3, our k is 3, then we have a3 3 over 3 plus 1 gives us 3 over 4, and so on. When our n is our k is equal to n minus 1, then an minus 1 becomes logarithm of n minus 1 over logarithm of n minus 1 plus 1, means it is simply n. Therefore an minus 1 becomes n over n minus 1 over n minus, we will see here it becomes n minus 1 over n plus logarithm of an is exactly equal to the nth term given here. Now again, let me remind you this: logarithm of x over y in base 10, which is common logarithm, is equal to logarithm of x minus logarithm of y, and therefore expand this one. Expand this logarithm, please. Expand. Logarithm of 1 over 2 means logarithm of 1 minus logarithm of 2, plus logarithm of 2 over 3 means logarithm of 2 minus logarithm of 3, and plus logarithm of 3 over 4 means logarithm of 3 minus logarithm of 4, plus and so on. Logarithm of n minus 1 over n means logarithm of n minus 1 minus logarithm of n, and plus logarithm of n over n plus 1 gives us logarithm of n minus logarithm of n plus 1. This term, logarithm of 1, is equal to 0. this is 0. Moreover, minus logarithm 2 and logarithm 2 cancel each other. It is 0. Minus logarithm 3 and logarithm 3 cancel each other. Here we have minus logarithm 4, and also the next one is logarithm 4, which is positive, cancel each other, and so on. And then this is also cancelled, and these two, because the same term but opposite in sign is in front of it, and therefore they cancel each other. And also here this cancel this one, logarithm of a minus logarithm of n plus logarithm of n gives us 0. Now we are left with minus logarithm of n plus 1. Here we have 0, everything is eliminated. Therefore Sn is equal to the sum of the first n terms, given that nth term is equal to minus logarithm of, in bracket, n plus 1. That is logarithm of n plus 1. This can also be written as follows by the rule of logarithm. This can also be written as Sn is equal, without using the negative actually, logarithm of, we can write like this one here, n plus 1 by the rule of logarithm. This is actually obtained by the rule of logarithm. Then here we have minus 1 here multiplied by logarithm, and therefore put minus 1 there. Moreover, again, a number the power of minus 1 can also be written as logarithm of, this can further be written as logarithm of 1 over n plus 1. Both are the answers. Both are answers here. This one and this one are the correct answer. This is exactly equal to logarithm of 1 over n plus 1. Logarithm of 1 over n plus 1. And therefore our answer is B. The one in B is the correct answer. But in case if this year the choices, in the choice you have seen something like this one, then immediately you have to choose this one, because both are the same. This one and this one are the same. That is enough for today. Let us see you in part 5 of my next video, and until then, have a good time and please study hard, since the examination, the entrance examination is approaching. You need to study hard, focus on your education, and have a good time. See you within 2 or 3 days with the next video. Bye bye.